Hello everyone, myself Paresh Mahendra Pandya. I am from Vishwakarma Institute of Information Technology from Pune, and I'm in the Department of Artificial Intelligence and Data Science. So problem that the problem solution that I'm going to show is mentioned as here. So ML for sustainability, satellite data processing for detecting pollution sources. So the task was given that the dataset comprises of 90 different animal images. Initially, we structured it for one versus rate classification, followed by binary classification, then classification problem. We evaluating each model basis of standard classification matrices like recall, precision, and fun score. The task is that we have organized the dataset into one versus others classification problem. Perform binary classification using existing architecture like EfficientNet, ResNet, etc. Then restructure it for five class classification. Use threefold validation technique on all of them. Then going to create a custom CNN function, train them without any help of any other architecture. Train the model, generate the classification report, plot the each layers, and look at the results. We're gonna look it here. So the solution I'm gonna show you today is that. So I implemented this whole project in PyTorch. As you can see, I have imported all the necessary packages, libraries, and modules required for this project. I created some helper function that may help you get file count is one of them. It returns it returns file number, how many files are present in that particular class. So using this function, you can look how many files are present in that particular data sets class. We're gonna look at is we're gonna have some random function. You can see using this random function, we can look at each images where you can see what this particular image is. It's just some random image taken from data our data set. So here wolf, the other may come as pigeon, and you can play around this to look at what are the other images in our data set. So we're going to create. So the another function is create CSV data set. We're going to create a central data file where we're going to have class name followed by its you can say um, image path length where the image is situated in the folder. We're going to create this. We're going to have this classes. Select k images. We're going to select the this k images. What we're going to do is then sample them across. So what we're going to do is we're going to only use some data for our modeling purposes, so it is efficient on time and resources. And other is the issue of class imbalance. So when we are going to use all those for OVR, later I'm going to describe what is OVR. It's going to have its consequences. Model will not be able to distinguish between so many classes. So let's go down. What we can do is gone through and did that sampling process, save the data set. This is some custom data set data loader that I created that will go into each and every class file like that here, and going to fetch that particular file name and its class name, and then we'll load it using a pillows image module, and going to open that image in it, and then re- the class name as well, convert them into three channels in RGB format, and then return the image for training purposes. Then we have devices. So devices are nothing but on which device you want to run, on the graphical processing unit or on the central processing unit. Uh, the others are weights. So efficient net B0 weights are nothing but uh, the efficient is a pre-trained model given by Google. I'm gonna use its weights for our task. You load the weights in the model. I'm gonna print the model how it's what's are its input function, what are the other stuff they have used. So it goes like, so the input function of the image is 224, 224, which is trained on 224, 224 size images with three channels. You can look at how they are, what is their input shape. Some max pooling function is used to reduce the um, size of this image. So it gets, so this is fine. The only result that we looked is the last number of features that were created is 1280 features. We're gonna use them for our binary classification problem. So this is just a training model where we have class name to be that. So what is OVR? So what one versus rest is nothing, where we're going to create models for n number of classes in that particular data set. So if we have 90, I'm going to create 90 models, each to perform binary classification task. For example, if I take, so it goes like that, we're going to take the unique classes in our data set. So one is antelope. So what we're going to do is we're going to take the all the images which are antelope, we're going to make them as one and all the other images as zero, and then train that binary classification problem. You're going to follow that for other n minus 1 classes and their images as well, and creating this n number of model. So in our example 90, then what we're going to do, we're going to use the pre-trained, what we're doing for prediction. How we're going to make them is we're going to give the image all to the the predictive image to all the the image for which the class has to be predicted, give to all the 90 data training to the model, and going to get the probability of them. Whichever has the highest probability for that one, we are going to assume, we are going to make the assumption is that that we're going to make that class to be its predictive value. So for example, if I the highest model, the prediction returns of one was 0.45, and bear in mind this all 90 we're going to add up to only one. So it is not everyone have some different values than them. Then going to have we are going to have one value. Then we're gonna look for we can look for another things as. So in this function, I have written this module function. Here you can see I'm going to use the default weights of B0 efficient net model, and be going to load this model. Going to use, I'm going to only use few trainable parameters, last trainable. So for example, this much only, and all others are going to be non-trainable. We have used nn.bca with log bits loss. Log bits, I use log bit loss because bca log loss function, binary cross entropy log loss function. It is better than that as it includes the sigmoid layer in itself, making it stable for our loss calculation. We're going to use train.optimizer model, Adam optimizer model, and then we're going to have this function more train going to be called. So train, this is nothing but training. So we're going to look at them one by one: training data loader, testing data loader, and etc. So one by one we're going to look at them. So we go here. So training data loader, testing loader. We have early stopping. I'm going to discuss it later on. We're going to have the binary classification. So we can have train step binary classification class. So he go here and going to get the image in X and Y as its label. Going to perform prediction on them. Going to squeeze them for proper can say metrics of proper shape of that matrix. Then I'm going to calculate the loss function, perform back propagation, and optimizer to zero for getting the calculation of this for future value. Then we're going to use predictive class where we're going to have sigmoid function on the probabilities given by our model. We're going to train the classification model and then going to calculate its loss. Same for the test function. Going to This is the helper function which combines everything. We're going to have plot of the loss curve. So training classification. This is nothing but some task to be performed onto the image. For example, resizing it for our particular pretend model size, then convert them into tensor. Apply normalization. So normalization is nothing but where we're going to convert whole image on the normalization values provided by ImageNet. Then I'm going to create. So in this line, I'm going to create a model for each classes. Then what we're going to have is the data set. We're going to have data set class. Then we have device, which we have CUDA or CPU. So for each class, we're going to look at how many, for each unique class, we're going to train the model by making that particular model as one and zero for other. Then we're going to have calculate the BCA with logs bit loss. Then we're going to have these values here. Then we're going to calculate these values according to it and create the new data set. And then data set is given to for k-fold for predicting the task. So you can see how it performed. So the training loss, as you can see, there is some room for growth as this model is a little underfit, but by tuning the hyperparameter, we can increase that in the future. Now look at 5 class classification problem. So we're going to convert this whole data into the subclasses, we can say antelope, and then into some main class into 5 class. Then we're going to have this training the model. This is the only difference between the above training function and this function is that this is for nn dot cross entropy loss function. So we're going to have softmax function here and a argmax function here. But rather above we're going to have sigmoid function and round function. So for 0 and 1, and this is to get which from which 5 class it belongs to. That is the only change made here, and rest is all same. Uh, so I changes all those necessary. I made all the necessary changes here. So I changes all the data. You can look at how they are represented now. I use a bigger model, thinking bigger model as we have some classes to be very small and having number of data points for particular classes to be small and for some other I have very large. I will implement so the early stopping. So early stopping is nothing here, but we're gonna calculate the difference between the validation loss and training loss, and if it is maximum then the minimum if it is maximum then the minimum if the loss is getting increased, what you're gonna do is after of some by some n delta, we're going to say that the overfitting start to happen, and we're going to increase the counter. And if the counter is less than minimum tolerance, then we're going to stop the early stopping. Using this early stop, we're going to stop the model. We're going to have train class. So this is just the above step, but for efficient net B5 model. Same as above model, but the features are 204 and the output feature is 5. I'm going to predict. So as you can see, the model is slightly bigger. So it starts to get overfitting a little bit. You can use smaller model for this classification. Even with the early stopping, it gets a little overfit in some epochs, but that is within the line of margin of error. So you can see it's not more, it bounce again back to its original value. So the last task was to create our own custom CNN model where we have torch, we have the classic uh, classification for our using custom CNN model. So I use convolutional 2D. I use Layer normalization. and nn.elu because it is more stable compared to relu. I can even go for celu, but testing for elu now. Training composition, resize it for if you I have reset it for a larger image size. Random horizontal flip, giving the probability of 0.2. They will randomly flip some images horizontal with the following probability. Convert the tensor and then going to perform normalization. If you want, you can remove the normalization here. Similar as above, I had trained using the same model training, but here is again binary classification task. Uh, this so so this is again binary classification task, but I still going to create two classes here, one for 0 and one for 1. I'm going to explain you later why I have did. But if you want, you can create 0 1 classification. Remember that if you're going to create 0 1 classification, please make 0 as your target level. So if antelope, for example, if you are going to perform OVR for antelope versus this, please make antelope as a 0 and all other value as 1. But for I have already done it for 1, so I'm going to use cross entropy loss here, and I'm going to use two output neurons. Same as above, going to train the model. You can see the result is much more less than efficient, but still it's going to come up to the 90 when after training the model. So you can look at this, how the training occurs. So this is the loss function. This is and some accuracy entropy. There are some overfitting happening. There is a probability of under fitting happening here, but we're going to handle by creating even further larger model or more efficient smaller model. So this was all the two tasks that were mentioned. The last task, that layer wise looking of the same. So I'm going to take the, for example, antelope, and then you can look at the model summary here. This is CNN explainer. We're going to explain each and every layer using GCamp and CAMP. So GCamp is gradient classification technique whereby what regions of the image were looked by CNN for making that, but while making that particular, you can say, classification, what features did it look for? Same for but it and same for CAM. It looks at the hot. It's look at it's going to show us the hot mapping region where the convolution layers have focus. So one is class mapping, gradient class mapping function, and very simple mapping function. So we can look what is the difference between them. So salient features, or overall, what features of or which pixels were looked for making the specification, you can see. So if I show you the original image, so this is that image. You can look at here, 05 B2 E9 AA818. You can see this image and the salient features which were looked by CNN. So this pixel mattered while classification. You can see it is looking at these features. CAM gradient, I explained it, gradient class activation mapping function. Behavior it looks, so you can, if it too dull, but you can look at which behavior it has saw for creating. So you can see here this mapping of this animal here. Then another function that I have used is CAM. So in CAMP, what we have done is you can look the hotspot regions of that particular image. You can see what hotspot were considered for it, and for making this particular classification, you can look it by layer by layer. You can give it more layer here, for example. So you can look what functions being used. So you can see what hot regions were made, were looked, which pixels to be were important for making this classification are highlighted here. You can make this layer by layer classic layer by layer task. You can look at them. This is the prediction function that I use. So softmax for cross entropy and binary loss function for binary classification problems. So sigmoid and softmax. We're going to have data set. We're going to look at data set. here. We're going to apply the normalization, open the image, going to divide the array, going to minus going to perform the normalization on the image, reshape them in according to which we have trained, uh, to unsqueeze the model on xs 0, so the matrices fit. For if it is for cross entropy loss, we're going to use argmax, and followed we're going to apply softmax function, then followed by argmax for predicting which class it belongs to, and for binary we are going to perform sigmoid on it, then rounding off the value to that particular class. Going to print that which class and what was its probability. By doing this, you can have the probability of that particular class. So this is for OVR function only. So for OVR, what you're going to do is you can loop through every class image and have the maximum value per class, and whichever after sigmoid has the maximum value in the binary classification, you can set that it belongs to that particular class. Thank you so much.